system, AFS, is designed to assist the pilot in flying the aircraft within normal flight envelope, FE, enhance safety, and optimize performance. Auto flight system includes the flight guidance, FG, system, the flight management system, FMS, the flight envelope, FE, and the flight control data concentrator, FCDC. The flight guidance provides lateral and vertical guidance, including speed or Mach control, in accordance with targets selected by the flight crew, or managed by the FMS. To targets, the flight crew selects input on the Auto Flight System Control Panel, AFSCP. These selected inputs go directly to the flight guidance for immediate guidance response. This is called selected guidance. The AFSCP is a short-term interface. The flight crew inserts the flight plan into the multifunction display, MFD, ahead of time. The FMS computes and manages these targets for the flight guidance. This is called managed guidance. The MFD is a long-term interface. Be either selected or managed, independently of each other. However, managed vertical guidance is not possible when selected lateral guidance is used. Note, speed or Mach can be either selected or managed, regardless of lateral and vertical guidance. AFSCP, the speed Mach, heading track, and alt knobs can be turned, pulled, and pushed. This enables the flight crew to pre-select or select a target, turn, engage a selected guidance, pull, arm or engage a managed guidance, push. When in managed guidance, the flight crew can take over control at any time and change to selected guidance. Note: the vertical speed flight path angle knobs can only be turned or pulled. The result of any action on the FSCP or on the MFD, manual or automatic selection, should be confirmed on the Flight Mode Annunciator, FMA, of the primary flight display, PFD. In order to achieve lateral and vertical guidance, including speed or Mach control, the flight guidance uses the autopilot 1 and or 2, a P1, a P2, the flight directors 1 and 2, FDs, and the auto thrust. The autopilot provides flight guidance by computing pitch, roll, yaw, and nose wheel steering orders. display flight guidance orders on the PFDs to the flight crew to fly the aircraft manually. When the autopilots are engaged, the flight directors allow the flight crew to monitor the flight guidance. Thrust controls the thrust to maintain the selected, or managed speed. S provides long-term guidance along the active flight plan. In addition to long-term guidance, the FMS provides flight planning. The flight crew can create a complete flight plan, lateral and vertical, navigation, aircraft position, position accuracy and radio navigation aids tuning, performance computation and optimization. Information display on the MFD, navigation display, ND, and PFD. The flight envelope is used by the flight guidance and the flight controls to prevent the aircraft from exiting the envelope. Control Data Concentrator, FCDC, determines the automatic landing capability for the autoflight system, in accordance with the availability of the equipment required for automatic landing. Interfaces the autopilot, flight director and auto thrust with the flight warning system, FWS, to allow the associated alerts to be triggered, and generates maintenance messages for the flight guidance and flight envelope. The FCDC also performs functions for the flight controls. Has 3 primary flight control and guidance computers, PRIMs, and 2 flight management systems, FMS-1 and FMS-2. Each FMS is operated by one of 3 flight management computers, FMCA, FMCB, or FMCC. The 3 primes control the flight guidance, autopilots, flight directors, auto thrust, the flight envelope, FE, and the flight controls functions. Prime can operate one or both autopilots, the 2 flight directors, and auto thrust. One prim is selected master, and the other 2 are slaves. The master prim is the prim that has the best operational capability, taking into account manual flight control law capability, flight envelope, autopilots, OTOLAN capability, and auto thrust capability. The master prim has priority to operate the engaged autopilots, flight directors, and auto thrust. If all prims have the same capacity, priority is prim 1, prim 2 and then prim 3. Slave 1 and 2 prims are on standby, ready to control autopilots, flight directors and auto thrust. The master prim loses the best capability. The slave 1 prim becomes the master prim. The engaged autopilots, flight directors and auto thrust are transferred to the slave 1 prim. The two other prims become slave 1 prim and slave 2 prim. Interfaces with these systems. This list is not exhaustive. There are two flight management systems, FMS, the FMS-1 on the captain's side, and the FMS-2 on the first officer's side. In normal operation, FMCA provides data to FMS-1, FMCB provides data to FMS-2, and FMCC is on standby, ready to provide data to FMS-1 and or FMS-2. Normal operation. If a P1 is engaged, FMCA is the master and FMCB is the slave. If a P2 is engaged, FMCB is the master and FMCA is the slave. Note: the FCMC on standby is regularly updated by the master FMC. Interfaces with the autoflight system via one autoflight system control panel or its related software backup on the MFDs, two multifunction displays MFDs, two keyboard and cursor control units KCCUs, two PFDs and their respective flight mode annunciator FMA, two navigations displays NDs, two FSCPs, one autopilot instinctive disconnect push button on each side stick, and 4 thrust levers and 2 auto thrust instinctive disconnect push buttons. The main autoflight system interfaces are related to the flight management systems. We will describe them in the following slides. MFDs display FMS textual data. The MFDs are the main interfaces with the FMS. They provide information on the flight plan, aircraft position, and flight performance. The MFD also is the interface for the FCU backup, surveillance system, and air traffic control, ATC. Flight crew uses the KCCU to navigate through the FMS pages on the MFD, enter and modify data on the MFD, and do some lateral flight plan revisions on the MD. PFD mainly displays primary flight parameters, bank angle, pitch, speed, Mach, heading, track, altitude, vertical speed, selected and managed guidance targets, for example speed and altitude targets, armed and engaged modes, landing capability, autopilots, flight directors, auto thrust engagement status on the FMA, flight director guidance orders, and instrument approach information. Displays lateral and vertical parts of the flight plan, and the related navigation information. The flight crew can modify the lateral part of the flight plan on the MD by using the KCCU. With the FS control panel, the flight crew controls the graphical and textual FMS data displayed on the related MD. The Auto Flight System Control Panel is the main interface with the flight guidance. Via the Auto Flight System Control Panel, the flight crew can engage managed or selected guidance, select targets for short-term guidance, speed Mach, heading track, altitude, vertical speed flight path angle, and engage APs, FDs and auto thrust. In case the Auto Flight System Control Panel fails, the MFDFCU Backup Auto Flight page provides all the Auto Flight System Control Panel functions. Levers are the flight crew interface with the auto thrust system. The daytime positions are sent to the prims. The auto thrust then sends thrust commands to the full authority digital engine control (FADEC) system, which regulates engine thrust. When armed or active, the auto thrust can be disconnected by any one of the two instinctive disconnect push buttons. Push button called the instinctive disconnect push button, located on each side stick, disengages the autopilot. And auto thrust are all integrated within the flight guidance. They operate in various modes in order to guide the aircraft along the lateral and vertical trajectory. Flight guidance modes appear on the Flight Mode Annunciator (FMA) of the PFDs. The flight guidance uses AP and FD lateral modes to control the lateral trajectory, AP and FD vertical modes to control the vertical trajectory and/or speed or Mach, and auto thrust modes to control either the thrust or speed or Mach. Some AP and FD, lateral and vertical modes are linked to form common modes. A common mode fulfills the objectives of both a lateral and a vertical mode. Land is an example of a common mode. The lateral objective is to guide the aircraft along the lock beam, and the vertical objective is to guide the aircraft along the glide slope beam. FMA can display 3 lines in each column. And shows in green the engaged modes. In our example, the speed mode is engaged for the auto thrust. This means that the auto thrust will manage the thrust to track the target's speed. The altitude mode is engaged for the vertical mode. This means that APFDs will provide guidance to maintain altitude. The heading mode is engaged for the lateral mode. This means that APFDs will provide guidance to the selected heading. Second line shows in blue or in magenta when there is a constraint, the armed modes. In the example shown, glide slope and localizer in blue indicate that glide slope and localizer capture modes are armed. The line shows reminders or messages. In our example, check approach cell advises us to check the consistency of selected approach. Flight guidance can be either selected or managed. Therefore, the corresponding modes are also referred to as either selected modes or managed modes. Note: the table shows you a few examples. AP and FD vertical mode determines the associated auto thrust mode. When an AP and FD vertical mode controls a speed or Mach target, the auto thrust mode controls thrust. When an AP and FD vertical mode controls the vertical trajectory, the auto thrust mode controls the speed or Mach target. During rollout and during flare, with the autopilot on, the auto thrust mode will control thrust at idle. If no AP and FD mode is engaged, auto thrust engages in speed or Mach mode in order to control a speed or Mach target. Note: the table shows you a few examples. Flight guidance mode and its associated target are managed when the flight guidance guides the aircraft according to the flight plan data computed by the FMS. Managed by the FMS, the speed target is automatically adjusted by the FMS according to the computed speed profile. The target is displayed in magenta on the PFD. Flight guidance mode and its associated target are selected when the flight guidance guides the aircraft to a target selected by the pilot on the auto flight system control panel. When selected by the pilot on the auto flight system control panel, the speed target is used by the AP and FD, or by the auto thrust as a target. The target is displayed in blue on the PFD. Any pilot action on the auto flight system control panel, or any automatic changes provided by the FMS, is displayed on the FMA and must be cross-checked. The following modules will deal with each element integrated within the flight guidance: FD, AP, auto thrust. Lay guidance orders on the PFDs. The flight crew can manually fly the aircraft by following FD orders, or, if at least one autopilot is engaged, the flight crew can use the FDs to monitor the flight guidance. The flight directors display guidance orders on the PFDs. The flight crew can manually fly the aircraft by following FD orders, or, if at least one autopilot is engaged, the flight crew can use the FDs to monitor the flight guidance. FDs: FD1 on the captain's PFD and FD2 on the first officer's PFD. The FD push button on the auto flight system control panel allows the FD bars to be displayed or removed on the PFDs. There is only one push button for FD1 and FD2. FD1 uses data from the systems on captain's side. FD1 uses ADRS 1. FD2 uses data from the systems on the first officer's side. FD2 uses ADRS 2. When in managed mode, FD1 guidance orders are computed by using FMS1, and FD2 guidance orders are computed by using FMS2. To engage both FDs, the following equipment must be available: 1 PRIM, 2 DRs, 2 inertial references, the Auto Flight System Control Panel, or the Auto Flight System Control Panel backup page, and normal law or alternate law in some cases. The FDs automatically engage at aircraft's power up. Engaged. The FD push button illuminates on the Auto Flight System Control Panel. 1. FD2 appears on both FMEs, and FD bars appear on both PFDs. Pitch and roll bars show pitch and roll guidance orders. Below 30 feet, during landing and takeoff, when a localizer is available, the roll bar is replaced by a yaw bar that gives lateral guidance orders. The roll bar is displayed if a lateral mode is engaged. The pitch bar is displayed if a vertical mode is engaged. The yaw bar is displayed when the runway, flare, and roll-out modes are engaged, along with the pitch bar in the runway mode, along with the roll and pitch bars in the flare mode, and alone in the roll-out mode. Not already displayed, FD1 and FD2 are automatically displayed if go-around engages. switch off the FD push button on the auto flight system control panel. The FD push button extinguishes. 1. FD2 is cleared from the FMA, and FD bars on the PFD are removed. Switch off the FD push button on the auto flight system control panel. If no autopilot was engaged, lateral and vertical modes disengage. If the auto thrust is engaged in thrust mode, auto thrust automatically reverts to speed or Mach mode, and if one autopilot was previously engaged, the autopilot lateral and vertical modes remain engaged. The FD bars automatically disappear if the aircraft's pitch exceeds 13 degrees down, or 25 degrees up, or the aircraft bank angle exceeds 45 degrees. The FDs, however, remain engaged, and the FD bars reappear when pitch and bank are less than those limits. In rollout mode, if the difference between the aircraft track and the runway track is more than 20 degrees, FDs automatically disengage. When auto thrust is not engaged, and the aircraft speed is below VLS, or above Vmax, or if a condition required for FD engagement is no longer met, or if both FD fail. The pitch and or roll bar flash for 10 seconds on both PFDs in case of reversion mode. Refer to protection chapter, or permanently flash on the respective PFD if a failure occurs in one of the equipment used for approach. For example, the ILS-1 receiver fails, or the MMR-1 fails, or the FLS function in MMR-1 fails. Pitch, roll, and yaw orders are not available when the FDs are engaged. A red FD flag flashes on the PFDs and then remains steady. The PFDs will not display the bars. A dual ADR failure leads to the loss of both APs and both FDs. Note, both FDs and both APs remain available in case of two-prim failure. When FD2, FD1 is lost, one FD1, 2 FD2 appears on both FMA. Generates pitch, roll, yaw orders to stabilize the aircraft, control the lateral and or vertical trajectory of the aircraft, control the speed or Mach of the aircraft, coordination with the auto thrust, and perform automatic landing and go around. Only one autopilot operates at a time. One autopilot engages when the flight crew presses AP1 or AP2. If the aircraft has been in flight for more than 5 seconds and The aircraft's pitch angle, bank angle, and speed are within operational limits. N. Autopilot 1 or 2 engages the Autopilot 1 or 2 push-button lights on the auto flight system control panel illuminates, and both FMEs confirm the autopilot engagement, Autopilot 1 or Autopilot 2. When one autopilot is engaged, the flight crew can engage the second autopilot by pressing the corresponding autopilot push button. Once the approach mode is armed, or active, or when the go-around mode is engaged. When both autopilots are engaged, Autopilot 1 is active and Autopilot 2 is on standby, regardless of the order of autopilot engagement. Autopilot disengagement occurs when either side stick instinctive disconnect push button is pressed, or the corresponding autopilot push button on the auto flight system control panel is pressed, or any side stick or rudder pedal is moved. Way to disconnect the autopilot is by pressing the side stick instinctive disconnect push button twice. Pressing the side stick instinctive disconnect push button once disconnects the autopilot and triggers the following temporary warnings. The autopilot off memo appears on the PFDs and on the engine warning display. A low volume cavalry charge sounds, and the master warning light illuminates. Pressing the side stick instinctive disconnect push button a second time extinguishes all lights. The auto thrust can work in two different modes, speed or Mach mode, or thrust mode. When in speed or Mach mode, the auto thrust continuously adjusts the thrust in order to maintain a speed or Mach target, for example during cruise or approach. Thrust mode. The auto thrust sets a given thrust, for example, maximum climb or idle. Auto thrust modes are automatically linked to autopilot and, or flight director vertical modes. When autopilot in our flight director vertical mode controls a trajectory, for example altitude hold, vertical speed, glide slope, the auto thrust is in speed or Mach mode, and when autopilot in our flight director vertical mode adjusts the aircraft pitch in order to keep a target speed or Mach, for example climb, descent, the auto thrust is in thrust mode. Thrust computes an N1 target that is sent to the forfait decks. Each lever position corresponds to a given thrust limit. There are four dead-ends: 0, idle, climb, flex MCT, toga. The flight crew uses the thrust levers to arm, activate, and disconnect the auto thrust, engage the takeoff and go around vertical mode, SRS, manually select the thrust of each engine when the auto thrust is disconnected, or engage reverse thrust on engine 2 and 3. Thrust can be active in flight, provided the thrust levers are set. Between idle and climb, all engines operating, or between idle and MCT, at least one engine out. Beyond these dead-ends, the pilot has manual control of the thrust. Auto thrust is either armed, blue, indication, active, white, indication, or disconnected, no indication. When the auto thrust is disconnected, the flight crew controls the thrust using the four thrust levers. Then, each of the four thrust commands is sent to its respective FADEC. Thrust arms during takeoff, when the thrust levers are set to toga or flex, MCT détente, in accordance with toga, flex auto-rated selection on the takeoff panel of the FMS performance page. Note: auto thrust also arms when go-around mode engages. Armed. Auto thrust indication appears in blue on the FMA. The first column of the FMA displays the selected thrust, and the auto thrust push button illuminates screen on the auto flight system control panel. The thrust becomes active at the thrust reduction altitude when the crew sets the thrust levers to climb détente, or MCT flexible détente, if at least one engine is out. When active, auto thrust is displayed in white on the FMA. Auto thrust becomes active if the auto thrust is armed and the flight crew sets the thrust levers on the active range, or the flight crew presses the auto thrust push button on the auto flight system control panel with the thrust levers in the active range or at the idle position. When auto thrust is active, the thrust lever's position determines the maximum thrust that the auto thrust can command. The pilot can at any moment set additional thrust by pushing the thrust levers forward from the climb détente. On the FMA, auto thrust is displayed in blue, armed, and lever climb is flashing. Set the thrust levers below climb détente. Maximum available thrust is limited by the lever's position. In this case, an auto thrust limited alert triggers. Thrust lever is displayed on the first column of the FMA, and lever climb or lever MCT in engine out configuration flashes on the first column of the FMA. Lever asymmetric message flashes on the first column of the FMA when the auto thrust is active, and at least one thrust lever is out of the climb détente when all engines are operative. Auto thrust disconnects when the flight crew presses either auto thrust instinctive disconnect push button. The flight crew sets all thrust levers at the idle détente, or the flight crew presses the auto thrust push button on the auto flight system control panel. When the auto thrust disconnects, the engine thrust target corresponds to the thrust lever position. Auto thrust also disconnects when the auto thrust becomes inoperative. In this case, the engine thrust target is frozen at the current thrust. If the flight crew presses and holds one auto thrust instinctive disconnect push button for more than 15 seconds, the auto thrust will be lost for the remainder of the flight. All auto thrust modes will be lost. The auto thrust off in flight, in order to avoid any thrust change at auto thrust disconnection, is: first, move the thrust levers back to match the thrust lever position with the actual thrust, and then disconnect the auto thrust by pressing any instinctive disconnect push buttons. Have a look at the link between autopilot, flight director vertical modes, and the thrust modes. Have a look at the link between autopilot, flight director vertical mode, and the speed or Mach mode. Control is managed when the target comes from the FMS, or selected when the target has been selected on the auto flight system control panel. In flight, either the APFD or the auto thrust can acquire and hold a speed Mach target. The speed Mach control is managed when the target comes from the FMS, or selected when the target has been selected on the auto flight system control panel. In flight, either the APFD or the auto thrust can acquire and hold a speed Mach target. Automatic switching when the crossover altitude is reached. During climb, The speed target, selected or managed, changes automatically to the related Mach target, and, during descent, the Mach target, selected or managed, changes automatically to the related speed target. Note: the crossover altitude is at approximately 30,000 feet based on the Econ Mach value. Manual switching. The flight crew can switch from speed to Mach by pressing the Speed Mach push button on the Auto Flight System control panel. Speed Mach target is managed. The Speed Mach window on the Auto Flight System control panel displays dashes. A magenta triangle on the PFD airspeed scale indicates the managed speed target, or the related speed of the managed Mach target. Managed speed Mach becomes active on ground when V2 is inserted on the takeoff panel of the FMS performance page and takeoff speed reference system engages, or in flight, when the flight crew pushes the speed Mach rotary knob on the Auto Flight System control panel if a managed speed Mach target is available. Note: speed Mach is also managed during go-around. The speed Mach is no longer managed and reverts to selected if the flight crew selects a speed Mach target by pulling the speed Mach rotary knob on the Auto Flight System control panel. The flight crew has pre-selected a speed Mach on the climb or cruise panel of the FMS performance page, and the related FMS flight phase engages, all APs and FDs disengage, and the FMS flight phase is not the approach phase, or the managed speed Mach target is lost. Get the managed speed Mach target according to FMS flight phase. Mach target is selected. The speed Mach window on the Auto Flight System control panel displays the target. A blue triangle on the PFD airspeed scale indicates the selected speed target, or the related speed of the selected Mach target. Selected speed has priority over managed speed. The only automatic change from selected to managed speed Mach target occurs at go-around engagement. If the situation calls for managed speed Mach, both PFDs and both MFDs display a message that proposes a manual change to managed speed or Mach. Short-term managed speed target may appear when the speed Mach is either managed or selected. This speed is indicated by a magenta dot on the PFD airspeed scale. A managed speed is displayed. The magenta triangle, or digital value, represents the long-term managed speed target, but doesn't take into account the aircraft configuration. Therefore, the current speed target used to command the aircraft is the short-term managed speed that is represented by a magenta dot. Then, a selected speed is displayed, blue triangle. The short-term managed speed represents the speed that will be commanded if the pilot switches to managed mode. AS concept is to combine the auto flight system, AFS, with the traffic collision and avoidance system, TCAS, to provide vertical speed guidance with autopilot and/or flight directors based on TCAS orders. In the next slides, we will see an example of APFDT CAS arming and engagement conditions. Assumption: the aircraft is in descent toward flight level 60. A traffic advisory TA is triggered when the aircraft reaches flight level 90, followed by a resolution advisory RA. Traffic advisory TA is triggered. The APFDT CAS mode arms in blue on the third line of the FMA vertical mode column. If another APFD vertical mode is armed, this mode remains armed and displayed on the second line of the FMA vertical mode column. The AP and FD engagement status does not change, that is, if both AP and FD are engaged, disengaged. They remain engaged, disengaged. Any engaged, armed. APFD lateral mode remains engaged, armed. The TCAS armed mode warns the flight crew that the APFD TCAS mode is available and that it will engage if the traffic advisory TA changes to a resolution advisory RA. APFD TCAS mode disarms when one of the following occurs: the intruder becomes white on the MD, or the APFD TCAS mode engages upon the resolution advisory, or the TA-only mode of the TCAS is manually or automatically selected, or the APFD TCAS mode fails. The ECAM triggers the auto-flat TCAS mode fault alert. When an RA, preventive, or corrective, is triggered, the APFD TCAS mode engages. The AP engagement status does not change. It remains engaged or disengaged. If the FD are disengaged, they automatically engage. Note: When the APFDT CAS mode engages, the triple-click oral alert does not sound, and the FD pitch bar does not flash. The auto thrust is disconnected. It becomes armed or active, depending on the position of the thrust levers. If the auto thrust remains active, the speed mach mode engages. The speed mach control becomes selected, and the speed mach target becomes the aircraft speed mach at the occurrence of the RA. If the auto thrust remains armed, the thrust target does not change. The FMA displays the auto thrust message in accordance with the position of the thrust levers. Example given: man thrust, man toga. APFDT CAS mode engagement. When the auto thrust is armed, the lever climb message may flash on the FMA. If the vertical speed order of the RA is above 500 feet per minute, the lever climb message is inhibited. However, if the speed exceeds VFE-20 knots, the lever climb message flashes on the FMA. If the vertical speed order of the RA is equal to or below 500 feet per minute, the lever climb message flashes on the FMA. Any engaged, armed APFD lateral mode remains engaged, armed. Note: if both AP and FD are disengaged, when the APFDT CAS mode engages, heading automatically engages. The heading target is the aircraft heading at heading engagement. The armed APFD vertical mode disarms, except Alt cruise, if the altitude capture is compatible with the RA order. On the resolution advisory and the AFSCP selected altitude, the APFDT CAS mode uses the guidance law of one of the following modes: vertical speed (VS) in this example, or altitude acquire, or altitude hold. Note: altitude acquire and hold guidance will be explained later on in this module. In this example, the APFDT CAS mode uses the guidance law of the vertical speed mode. The vertical speed target is the limit between the green and red area of the vertical speed scale, with a margin of 200 feet per minute within the green area to avoid the red area. Adjust vertical speed, adjust oral alert is triggered. This APFDT CAS mode guides the aircraft toward the new vertical speed target. Factor authority of the APFDT CAS mode is increased up to 0.3 G. The APFDT CAS mode ensures that the aircraft speed remains between VLS-5 knots and Vmax. Clear of conflict, oral alert sounds. The APFDT CAS mode automatically disengages and reverts to armed mode, TCAS, as long as the intruder remains within the TA range. The APFDT CAS mode reverts to vertical speed mode. The vertical speed target becomes plus or minus 1,000 feet per minute. That leads the aircraft toward the AFSCP selected altitude. Alt arms. A triple click will alert sounds, and the pitch bar flashes for 10 seconds. Note: the vertical speed target becomes 500 feet per minute if the aircraft is at or above 30,000 feet, and the AFSCP selected altitude is above the aircraft. Intruder becomes white on the ND. The APFDT CAS mode disarms. The PFDT CAS mode also automatically disengages if one of the following occurs: the TA-only mode is manually or automatically selected, or the standby mode of the TCAS is selected, or the ECAM triggers the APFD auto flat TCAS mode fault alert, or the flight crew engages another APFD vertical mode, example given in the case of go-around. The next slides, we will see some examples of preventive and corrective RA. Example: a preventive TCAS RA monitor vertical speed has been triggered. The TCAS mode engages and maintains the current aircraft vertical speed using the alt law. The lateral mode, example given localizer, is maintained. Note: if glide slope is armed when the APFDT CAS mode engages, glide slope disarms. The approach push button comes off, and the localizer push button comes on. The aircraft is initially in cruise and experiences a corrective TCAS RA climb, followed by adjust vertical speed, adjust, or warning. Alt cruise is armed. In the case of corrective, adjust vertical speed, adjust, or preventive, monitor vertical speed. The capture of the selected altitude is allowed under TCAS mode if the level is reached before the clear of conflict, using the Alt-Star law. The flying reference is track FPA when APFDT CAS mode engages. The flying reference automatically becomes heading vertical speed. APFDT CAS mode disengages. The FMA displays track FPA deselected message for 10 seconds on the third line. CAS mode arming and engagement are inhibited when the TCAS is selected in TA-only mode, either manually by flight's crew action or automatically if below 900 feet radio altitude, wind shear, stall, TAWS alerts are triggered. When the TCAS is in standby mode. In the next slides, we will see some examples of inhibitions. Case of a wind shear alert. The PFD TCAS mode disarms due to the automatic TA-only mode selection. HUD option. In the case of a wind shear alert is triggered, wind shear message appears on the HUD combiner. For additional information on the HUD, refer to A380 HUD presentation. TA only, standby, mode of the TCAS is automatically or manually selected during NRA. The PFD TCAS mode automatically disengages and all the following simultaneously occurs. The PFD engagement status does not change. The PFD TCAS mode reverts to vertical speed mode. Vertical speed target is vertical speed target value at the TCAS mode engagement if positive, or 0 feet per minute if the RA was to descend. A triple click all alert sounds and the FD pitch bar flashes for 10 seconds. The PFD lateral mode is maintained. The FMA displays TCAS RA inhibited message on the second and third columns of the third line. The APFD TCAS mode is not available. The ECAM displays the audio flat TCAS mode fault alert. Note: do not confuse with SURF TCAS 1+2 fault alert when the TCAS system fails. Flight crew uses the HUD. When a TCAS RA is triggered, the flight crew must revert to the PFD. TCAS RA, revert to PFD message appears on the HUD combiner. For additional information on the HUD, refer to A380 HUD presentation. You are at flight level 350. Flight director, auto thrust and autopilot are engaged. Notice the intruder at 12 o'clock.
Traffic.
TCAS blue.
Descend. Climb now.
The crew monitors carefully the behavior of the autopilot and is ready to take over if needed.
Monitor vertical speed. conflict.
Vertical speed minus 1000. Alt cruise star. Alt cruise.
You are at flight level 350. Flight director, auto thrust and autopilot are engaged. Notice the intruder at 12 o'clock.
Traffic, traffic.
Tika's blue.
Descend,
Tikas.
descend. Climb, climb now, climb now.
The crew monitors carefully the behavior of the autopilot and is ready to take over if needed.
Monitor vertical speed. Clear of conflict.
Vertical speed minus 1000. Alt cruise star. Alt cruise.
You are downwind, flying manually track FPA. Notice the intruder at 1 o'clock.
Traffic,
Tika's
traffic.
blue.
Descend,
Tika's heading 1FD2 auto thrust lever climb.
Notice the automatic re-engagement of flight directors and auto thrust. In this example, the pilot flying decides to engage the autopilot.
Clear of conflict.
Vertical speed plus 1000. Vertical speed plus 1000. Alt star. Alt star. Alt. Alt.
You are downwind, flying manually in track FPA. Notice the intruder at 3 o'clock.
Traffic,
Tikas
traffic.
blue.
Traffic,
Tikas.
traffic. Descend, descend.
Speed Tikas heading 1FD2 auto thrust lever climb.
Notice the automatic re-engagement of flight directors and auto thrust. In this example, the pilot flying decides to follow the flight director manually.
Monitor vertical speed. Monitor vertical speed. Clear of conflict.
Vertical speed plus 1000. Vertical speed plus 1000.